and welcome to Lesson 6, made by the American Institute of Techniques and Management. In this lesson we will continue the path of functions and everything associated with them. I will be concentrating on statistics and basically statistical functions. For the beginning, I will go back to the topic of average, median, and mode functions. So let's open a new file. Yeah, here it is. Great. It's named book 1 right now. Okay. So, first off, we will name these three cells as average, median, and mode. Okay. And let's just to have a table. Median and mode. Okay, great. Let's have numbers from 1 to 20. Of course, what I'm doing is adding extra numbers just to have the positive result in every function. But as you remember, some of these functions work in a way that require a few same numbers. So 13, 14, and maybe let's just drag and drop them to number 20. Yeah, that's great. So we have our table of basic numbers, which we can use. So let us input the, maybe let's delete, what I probably forgot to address before. We have a possibility to actually remove each and every row and column. So I will show you how to do this because this is a good opportunity. So you mark the entire row and push the right mouse button. And here you can see that there are many possibilities like cut, copy. You can basically do everything you can do on a cell, on a row and a column. So let's delete this one just for just to better see the entire workbook. Okay, so maybe let's input some colors here. Yeah, and let's begin with the average. So what you want to do is begin with the equals marker and write in the function. Okay, so Excel actually shows us the function average, and let's mark these numbers. Great. As you can see, the input for this function is basically the numbers. So by marking the entire table, it's much easier than just marking each and every cell. Enter. So the average for this function is 10.1. So what this does is actually marks all the numbers and calculates them by, adds them and divides them by the number of the numbers. So the median. Okay, and let's do the very same thing. Great. So the median is 9. Well, how does the median work? As you remember, I said that the median is the middle value in a sorted list of values. So in this concrete table, we have 20 values. So by dividing it into 2, it would be, let's number them, just to show you where the middle would be. Oh, we actually have 24 values, of course. So the middle will be over here. And what we do here is we add these two and divide them by 2, because here's the middle. We do not have a singular answer for this for this median. So we have to divide the middle ones by 2. Okay, and the mode. So we'll be using the SN returns the most frequently occurring. Yeah, exactly. Okay. Okay. So as I said before, this value actually gives out the most occurring value. Well, this might be a dumb coincidence that these two are actually the same, but if we change this one to 10, you can see the difference. How come? Because these two are the middle, so it's added up and divided by 2, and 9 is still the most occurring number because there are actually 3 and there are no other numbers that occur so often. Okay, the task for you right now is to use the average, median, and mode. Create your own table of numbers, numbers from 1 to 50. Try to segregate them from the lowest values to the highest values. And that's it, basically. Just do not go over 50 values. I guess that would be great. And input your answers for your tables over here in your file, and name them average, median, and mode. And that's your task for now. Okay, great. Okay, so let's imagine a different scenario. Let's say there are 3 people. Let's name them person A, B, and C. And each of these people have bought lottery tickets. First person wins nothing, second person wins nothing, and the third person wins 3 times. Okay, so the average number of wins in this group is 1. That is, well, if you're using the mean as the average. This doesn't sound like a good deal for all of them if you use the average. Each person who used it got a win. So basically, each of these people would have to divide the money between themselves. On the other hand, both of the median and the mode equal 0. Well, the median equals 0 because that's the middle value in the sorted list, and the mode equals 0 because that's the highest occurring value. As you can see, statistics prove that the lottery gives 0 wins on average. Well, sort of. Look at another example. Let's say I will put in some numbers. Let's say student grades, right? I will input them right now. Look at this example. Here you have the average, here you have the median, and here you have the mode. Let's copy these so you can see them perfectly. Great. The numbers are shown over here. So imagine this situation. This is a distribution of grades. As almost always happens, the mean, the median, and the mode each return a different number, as you can see. Strictly speaking, we should say that the average grade is 86.72, the mean value. But if the teacher or the school wants to make their impact on students look better, they could point out that the most frequently occurring score is 94. This is the mode, and sure enough, 3 students did receive 94. But is this the best representation of the overall results? Well, probably not. Working with the functions that return these measures of central tendencies, average, median, and mode, can make for interesting and sometimes misleading results. Next up is, well, measuring variance. calculating the mean from a group will not reflect that variety. Suppose you are doing a survey of salaries for different occupations, and the occupation A has a mean salary of $75,000 a year, and occupation B has the same mean of $75,000 a year. Does this mean that the two groups are the same? Well, not really. Suppose that in Group A, the salaries range from 65 to 85,000, but in Group B, they range from 35 to 1115,000. This difference, how much the value differ from the mean, is calculated variance. Excel provides you with functions to calculate the evaluate variance, and this is an important part of many statistical presentations. Measuring variance is a measure of how spread out of a set of data in relation to the mean. Variance is calculated by summing the squared deviations from the mean. Well, so how to calculate the mean? Calculate the mean of the set of values. So to do this, let's create a different sheet. Let's say this one was the average, median, and mode. And here we will write the variance for now. Okay, great. Let's use the same statistical data as we did before. Great. So we have the same sum we used to. So I won't do the actual calculation here, but just for you to understand how Excel works. First off, we calculate the mean of the set of the values. So you would have to calculate the mean of all of these values, then calculate the difference from the mean for each value. So you have to calculate the difference between the each and every value and the mean. Then square each difference. So we just do the square and then sum up the squares. So we do the sum of the square of these values. Divide the sum of the squares by the number of items in the sample minus 1. And that's basically the math. So a sample is selected set of values taken from the population. A sample is easier to work with. For example, any statistical results found on 1,000 sales transaction probably would return the same or close to the same. Results if run on the entire populations of 1,000 transactions. So, what is the actual function we can use to use it as Excel will show us? Well, the function is var s and var p. So how about we use one of the functions? So we write down equals var, and let's to show you the difference between these two. So var p calculates variance based on the entire populations, ignores logical values and the text in the population, and var s estimates variance based on a sample, ignores logical values and text in sample. So for this one we will be using the var s. We choose the numbers and we look it up. And as you can see, this is our variance. Just to explain how it worked. So the variance calculation on either of population of data or a sample of the population. So the var_s function calculates variance on a sample of population's data. The calculation is slightly different in that the denominator for variance of a population is the number of items. So for a just to show you how the var_p would work, and let's use the same amount of data. So you can see there's an actual slight difference between these two, because var s is a function that calculates on a sample of population's data, and var p is a variance on the full population. So the calculation is slightly different in that matter. The denominator for variance of a sample is the number of items less 1. So this is basically the most basic statistical data you can get from these two. So what I want you to do is actually use these two, and please give it a thought. How do you think they differ? var.s and var.p. So use your own variance of data and imagine a situation when you could be using them. Okay, moving on. Analyzing the deviations. So, often finding the mean is an adequate measure of a sample of data. Sometimes the mean is not enough. You also want to know the average deviation from the mean. This is finding the average of how far individual values differ from the mean of the sample. For example, you may need to know the average score on a test and also how far the scores, on average, differ from the mean. Average deviation is another way to specify variance. So, I will be using a new function which is called the AVEDEV. So, just to AVEDEV function. Let's use this function over here. So, basically, this is another statistical function which is, well, worth mentioning. I will explain what it does in a second so that you see how much it differs from the others. So, the AVEDV function averages the absolute deviations. In other words, negative deviations where the data point is less than the mean are converted to positive values for the calculations. For example, a value of 10 has a deviation of minus 40 from a mean of 50 divided by 10 minus 50 equals minus 40. However, this function uses the absolute value of the deviation. 40 is instead of minus 40. Here I have written down 3 more interesting statistical functions, but I want to go over them because they're pretty complicated regarding math points. So just to show you where they are, you have the statistical category and go over the k-curt function. So it returns the kurtosis of a data set. If you have any problems with this, you can always go on to the help on this function button, and this will actually give you a proper answer with examples of usage for this function. You can read a bit more about it. As I said, the definition and everything regarding it could be pretty problematic, so if you feel well in math, you can go over it. If not, you can go over standardize. This function is actually not so complicated, but still requires pretty much here pretty much a lot of time, which I don't want to use over here to explain every detail of each and every function. But just to sum it up, the standardize function uses, well, actually 3 types of data to calculate. It's the value you want to normalize, the mean, and the standard deviation. everything is pretty well explained in the help function in the help part of Excel. So please read a bit about these three functions, and if you feel up to it, try creating at least three answers for each of them, just to see the variance of answers you can get in every of these functions.